Hi everybody, this is Algebra 1, Lesson 61, and in this lesson we're going to cover subsets and subsets of the set of real numbers. Alright, if all the members of one set are also members of a second set, the first set is said to be a subset of the second set. There's a lot of sets in that sentence. Alright, so I'll show you what that means. The main word we're looking for right here is subset. Alright, so set B has 1 and 2 in it. Set A has 1, 2, and 3. B is a subset of A. All the members of B are also in A. So we got a 1 and a 2. And A also has a 1 and a 2. So that means B can fit into A. So B is a subset of A. We use this little stretched out C to mean is a subset of. So this would be read B is a subset of A. A slash can be used to negate the symbol, so A is not a subset of B. A has 1, 2, and 3 in it. B only has 1 and 2, so A cannot fit into B. So A is not a subset of B. Okay, so our slash through means is not. Okay? Two sets that have the same members are called equal sets. A and B are equal sets. 1, 2, and 3, 1, 2, and 3. The set that has no members is a subset of every set that has members, and it's called the empty set or the null set. And it can be written as like that, so there's nothing in it. That and is the null set. So that means that our null set, let's say that we have A, B, and then we have C, is the null set, no members. We could say C is a subset of A, and C is a subset of B. Oh, that looks terrible, my symbol. All right. C is a subset of B, but B would not be a subset of of C, because C has no members, but B does have members. A could not be a subset of C. So C is a subset of A and B because it doesn't have any members. All right. Okay, so given sets D, E, and G, tell which of the following are true and which are false and why. All right, so these are what your problems are going to look like. All right, so E is a subset of G. So let's look at E. E has 1, 2, 3, 4, 5, 6, 7. So all the numbers after 1 are included in set E. And it's saying E is a subset of G. G only has 1, 3, and 5. So that one is going to be false because we cannot fit E into G. All the members of E are not members of G. 2, which is an element of set E, is not an element of G. So in E, we have a 2. In G, there is no 2. Okay, so that one's false. B. G is a subset of E. All right, so let's look at G. G has 1, 3, and 5. E has 1, 3, and it would have 5 because this means 4, 5, so 5 would be in it. So that one is true. All the members of G are also members of E. All right, next one is D is a subset of E. So let's look at D. 0, 1, 2. Does E have 0, 1, and 2? Well, it's got 1 and 2, but it doesn't have 0. So that means that one is false. All the members of D are not also members of E. All right, let's review some of the different ways that we have categorized numbers here so far. This is basic number theory. Natural numbers are 1, 2, 3. Those are going to be our counting numbers. Remember that. Whole numbers are the counting numbers plus 0. Integers are our negative numbers plus our whole numbers. Okay, so those are the ones we already know. Now we're going to learn a new set. Every real number is either a rational number or an irrational number. A rational number is a number that can be represented as a fraction of integers. So 1/4 is a fraction. -3/17 can be a fraction. 10, -10, that could be over 1, so that would be a fraction. This one, we could put that over 1, make that be a fraction, or it would be the same thing as 13 over 1,000, okay? So those are all rational numbers. Irrational numbers, the square root of 2, the square root of 3, the square root of 5, the square root of 6, pi, those are all irrational numbers. They cannot be written as a fraction. The square root of a counting number is either a counting number or an irrational number. So when we look at it and we say the square root, okay, so the square root of 9, that's a counting number. So that one is not an irrational number. The square root of 9 is rational. The square root of 2, we don't know what that is. We'd have to use a calculator, and it's going to be some crazy fractional number, so that one's irrational. Okay? If it's not a counting number and it's a square root, then it's an irrational number. The product of an irrational number, product means multiply. The product of an irrational number and a non-zero rational number is an irrational number. So that means if I had 3, which is rational, times the square root of 2, which is irrational, I'm going to get an irrational number. The sum, that means add, of a rational number and an irrational number is an irrational number. So 3 plus the square root of 3 is going to be irrational. All right. Okay, so here we have this diagram of the different sets of numbers. Okay, so in this big box right here that holds all these numbers, in this set are the real numbers. Real numbers are going to be all your numbers that are not imaginary numbers, and we'll learn imaginary numbers in Algebra 2. So in the set of real numbers, we have either irrational numbers or rational numbers. Irrational numbers are real numbers that cannot be expressed as a fraction of two integers. So examples of that, the square root of 2. Pi is an irrational number. Okay. Rational numbers, those are real numbers that can be expressed as a fraction of two integers. So like 1/3, -4, 12. Those are rational numbers. Okay. Inside this umbrella of rational numbers are integers. Integers is a set of whole numbers and the opposite of the natural numbers. So in our rational numbers, we're going to have our integers, which are going to be, remember the set of integers will be -3, -2, -1, 0, 1. Oh, we got our dot, dot, dot going on forever that way. 2, 3, dot, dot, dot. So there's our set of integers. Next, inside the set of integers included within that are going to be our set of natural numbers. So those are going to, the whole numbers are going to be the natural numbers and 0. So that's going to be 0, 1, 2, 3, and then on forever that way. And then our natural numbers are the same as our counting numbers. So those are going to be without 0, 1, 2, 3, dot, dot, dot. There we go. All right. So those are showing how this one is a subset of this one. And this one right here is a subset of that one. And that one's a subset of real numbers. Okay? All right. Now, remember this symbol means is a member of. Okay? So, what subsets of the real number? So, 1/2 is a member of what subsets of the real numbers? All right, so real numbers, it would not be an irrational number because it's written as a fraction, so it's going to be rational. would it be an integer? Integers are whole numbers, so it's not an integer because it's not a whole number. So it is just part of the rational numbers. So rational numbers and real numbers. Because remember, real numbers was our big box. All right. 5, what subs 5 5 is a member of what subsets of real numbers? Remember that little e there, that stretched out e means is a member of. Okay, so if we go back to our chart, we could look at that, or we could just think about it. So let's see. We've got our real numbers. It's going to be a real number. Is it rational or irrational? Well, it could be written as a fraction, 5/1, so it's rational. All right, then we've got our integers. Is it included in the integers? Yes, that's going to be all your negative and your positive numbers, so it's an integer. Whole numbers, yeah, it's a whole number. That's going to be all your numbers, including 0. And then your natural or counting numbers. So it's going to be a natural number. All right, so the answer to a question like that would be all of these subsets. Okay, so 5 is included in all of those subsets. All right, 3 times the square root of 2 is a member of what subsets of the real numbers? Okay, so we start off with, and use this chart. Go back and look at it if you need to. So I'm going to copy this so that I can put it on there. I don't know what I just did here. Go back to it. So this chart right here, I'm going to copy that so I can paste it over there by the questions so we can look at it while we're figuring these out. Erase all that. All right. Okay. Go back to our question. All right, here's our chart so that we can look at it. All right, so we've got 3 times the square root of 2. So we remember that, whoa, what did I just do? There we go. We remember that anything, we know that the square root of 2 is an irrational number. And anything that's multiplied times an irrational number, the answer is going to also be an irrational number. So we can see that this is part of our real numbers. So we would write reals. And it's going to be an irrational number. And that's the answer to that one. Okay, so this next one has a whole bunch of parts to it. Tell whether the following statements are true or false, then explain why. All right, so this says A, real numbers are a subset of the integers. So I'm going to need my chart to do that. And I'm going to move it. Let's see, can I move it over to right down here? All right. All right, so the real numbers are a subset of the integers. So let's look. Our real numbers are inside the integers? No, integers are a subset of the real numbers. So that first one there is false. Okay, see how this is a big giant box, and for it to be a subset, one box has to be inside the other box. So we've got real numbers are a subset of integers. No, integers are a subset of real numbers. So this one is false. All right, irrationals are a subset of real numbers. So here's our real numbers is the whole box, and irrationals are inside that real number box, so that one is true. All right, irrationals are a subset of rationals. Are the irrationals inside the box of the rational numbers? No, those are opposite of each other, so that one's false. Whole numbers are a subset of the natural numbers. So here's our whole numbers there. And are they a subset of the natural numbers? No, the natural numbers is a box inside the whole numbers. Whole numbers box doesn't fit into the natural numbers box. So that one is also false. Last one, integers are a subset of real numbers. So integers right here are inside the real number box. Yes, so that one is true. Okay. All right. Do the practice problems. I know it's kind of long. They go all the way up to F, but they're not super hard. You can look back at that chart with the boxes in your book. It's on page 249, so use that chart to answer the questions. All right, so pause the video, do those practice problems. All right, so practice A. This one has some sets, and we're supposed to tell if they're subsets of each other. So we've got set A, B, and C. Tell which of the following assertions are true and which are false, and then explain why. All right, so the first one says B is a subset of C. All right, B has 0, 2, 4, and 6. C has, I can't see it, I have to move my screen a little bit, 1, 3, 5, and 7. All right, so are the members of set B also members of C? 0, nope. 2, nope. 4, nope. And 6, no. So that is false, because the members of B are not also members of C. All right. The second one is B is a subset of C. So B, we got 0. Oh, I wrote the same thing twice. This one was supposed to be A. Whoopsie. Okay, let me fix that. All right, B is a subset of A. There we go. Erase that. Let's see if it is. Okay, so we've got B, 0. Yes, it has 0. 2, yes, it has 2 right there. 4, it would be 4, 5, 6. So it's going to include 4 and 6. So that one's true. Sorry about that, guys. I wrote my problem down wrong. Okay, because all the members of B are also members of A. Okay, and then C, we already said that the members of B are not members of C, so that one's false. And then this last one, C is a subset of A, so 1, 3, 5, and 7. 1, 3, yeah, it would have 5 and 7 because it just keeps counting up, so that one is true. All the members of set C are also members of set A, so C is a subset of A. All right, this next one, we are going to need our little box that shows us our number relationships here. Move it to where we can see it. All right, so we're going to use that to answer these questions. So 11 over 6 What subsets of the real numbers? Well, first of all, they're all going to be real. Okay. Big box. All right. And then is that rational or irrational? That would be rational because it can be expressed as a fraction. Would it be an integer? Set of whole numbers and the opposite of the natural numbers. No, it would not be an integer, so then we can stop because everything else is inside the integer box. So if that it's not an integer, then it can't be a whole number or a natural number. All right, next one, 1.62. That would be a real number. It would be a rational number. You could write that as a fraction. But it would not be an integer because integers have to be whole numbers. So we can stop there. All right, the number 4. 4 is a real number. It is also rational because we could write it as a fraction. It is an integer because it's a whole number. It is a whole number. And it's a natural number because we say it when we count 1, 2, 3, 4. All right, 2 times the square root of 2. All right, that's going to be a real number. But it is not a rational number. It's in the irrationals because square root of 2 is irrational. That one is irrational. And we remember that if we multiply something times an irrational number, we get an irrational number. All right, negative 4. That's a real number. Is it irrational or rational? That would be rational because you could do negative 4 over 1, and you could write it as a fraction. So that's rational. It is also an integer because it's a whole number or the opposite of the whole number. So integer. All right, is it a whole number, set of natural whole numbers and the number 0? No, it's not in that one. Remember, this is just 0, 1, 2, 3. It does not include negatives in with the whole numbers. Okay, negatives are included with integers, not whole numbers. All right, so we can stop there. All right, so that's the answer to those. And that is it for this lesson. Thanks for watching.